right? So you can have like different categories of classification problems. As I said, you can have digit classification. So for that, we have MNIST data set. And this is roughly like 60,000 images. And the images look something like this. So each image is corresponding to one of the digit. Right? And the classification task is given each of this image. You have to say which digit is present. And then again, we have a multi-MNIST. In that case, I don't have the samples, but it will look something like this, but you will have multiple digits on same image. Okay. And then again, we have this SVHN data set. Again, this is also digit classification. And these are, you will say like more realistic images, because these were extracted from this HN represent like house numbers. Okay, so these were extracted from real house numbers, and you can assume that they will be very noisy. And again, but each of those images are actually corresponding to one of these digits, not as clean as this. Then we can have object classification. Again, we have several data sets here. We have CIFAR 10. It's called 10 because there are 10 different classes. Then we have extended version of that, which is CIFAR 100, where we have 100 different object classes. And then, of course, we have ImageNet, where we have billion of images. And again, there are different subsets of this. This standard one is like 1,000 classes. So if you have to solve the classification problem on this data set, it will be 1,000 classifier. All right, so again, classification, you can call that object recognition as well if you're interested in some set of object categories. And as we discussed earlier, a simple variation could be binary classification, where if you're interested in persons, the question will be whether person is present in the images or not. And your classifier should provide you this answer, either yes or no.